Hi everybody, I'm Sophia, one of the members of Seattle INTEGIRLS, and today I'm going to be going over our Seattle's INTEGIRLS Spring 2026 Middle School Competition solutions for questions 1 through 5. So let's just get started. We have our first question here. I'll read it out loud. Aaron, Alex, and Amo are playing Brawl Stars. They are the only 3 players on the red team, and they are playing against the blue team, which also has 3 players. Amo gets 10 more kills than Alex, who gets 1 more than Aaron. Given that the players on the blue team died 21 times in total, and that the number of blue team deaths is equal to the number of red team kills, how many kills did Amo get? Okay, so this one is pretty straightforward. We know we have 3 players on the red team, so let me highlight this. 3 players on the red team, and Amo gets 10 more kills than Alex, who gets 1 more than Aaron. So let's just say Aaron equals X. So if Aaron got X kills, that means Alex must have gotten X plus 1 kills, because it says that Alex got 1 more than Aaron, and we know that Amo gets 10 more than Alex. So that means we can say Amo got X plus 11 kills, since that's 10 more than what Alex has. Then in total, if we add these all up, we get 3X plus 12 kills. And we know that the number of kills is the number of deaths on the blue team, and the death on the blue team is 21. So we can say that this must equal 21. Then subtracting 12 from both sides, we end up getting 9 equals 3x, meaning x equals 3. This represents Aaron, right? And the question actually is, how many kills did Amo get? So this is really important. And since Amo is equal to x plus 11, and we know that x equals 3, then our total answer is 3 plus 11, which is equal to 14. So our final answer for this question is 14. Okay, now moving on to the second question. This one is a bit tricky. It says, what is the remainder when 6 to the 67th power plus 7 to the 67th power is divided by 5? So obviously these numbers are going to be very big, so we don't want to compute these out. And what we actually are looking for here, what we're testing, is the units digit. This is really important. So what is the units digit of 6 to the 67? Well, let's just list some out first. You know that 6 to the 1 equals 6, 6 to the 2 equals 6, 6 to the 3, or this doesn't equal 6, this equals 36, but it ends in 6. 6 to the 3 is 216, that also ends in 6. So this pattern is that no matter what it's raised to, it always ends in the unit digit 6, which means that this should also end in 6. Let's just mark that. And then we move on to 7 to the 67. So this one's a little trickier. So 7 to the 67th power, let's just start off small. So 7 to the first ends in 7. 7 to the second is 49, so that ends in 9. 7 to the third ends in 343, so that ends in 3. And then I don't actually know 7 to the fourth, but we know that ends in 7, because if we multiply by 7, we get 1. So it ends in 1, and this actually repeats. So it goes 7, 9, 3, and then 1. Oh, actually, I realized this is cut off, so I actually meant to say that this is 343. So now we know that this pattern repeats by 4. So the real question is, what is the remainder of 67 when divided by 4? So we know that 67 is 64 plus 3. So we know it must have a remainder of 3. And knowing this, if we know there's a remainder of 3, again, let me make this a little more clear. Then we look for 7 to the third. And we see here this ends in 3. So now that we add these two up, we get a total of, let me actually make a new slide, or at least scroll down, or scroll up in this case. So again, to remind ourselves, we have the 6 from the 6 to the 67th, and we have the 3 from the 7 to the 67th. We add this up, we get 9. But the question is, what is the remainder when divided by 5? And we know that things, when they're divided by 5, or divisible by 5, they end in 5 or 0. So the closest thing to 9 is 5. So 9 minus 5 is equal to 4. So we get a final answer of remainder 4. And that's our final answer. So just to reiterate, what we did is we looked at the units digit and we followed patterns. So for 6 to the 67th, we noticed that they all end in 6, no matter what. Then for 7 to the 67th, we notice that they repeat in a cycle. They end 7, 9, 3, 1. So we just find, since this is a cycle of 4, we find the remainder when 67 is divided by 4. That remainder is going to correspond to that units digit. Then we add it up, and then we subtract by 5. Hopefully that made sense. Now moving on to our third question. Let p be the 67th smallest prime number. Find the remainder when 67 times p squared is divided by 12. So again, something very interesting here is obviously it's going to take too much time for us to figure out which value of p is actually the 67th smallest prime number, right? One fun fact is that there are 25 primes below 100, but again, big numbers, we don't want to deal with this. So let's just generalize it. We know we're dealing with 67p squared. Oh, that actually did not work the way I wanted it to work. Okay, 67p squared. Another really interesting thing is all primes are odd except for the first prime, which is 2. And we know that the 67th smallest prime number must be odd as well. So what we actually essentially have here is 67, which is an odd number, times p squared, which is also an odd number because odd times odd is odd. And again, odd times odd is odd, so this is going to be an odd number. Now, when we have an odd number and we're finding the remainder when it's divided by 12, we know that remainder is going to be odd because anything multiplied by an even number is even. And so odd minus even is odd. So we know that our remainder is odd. This is so key. So essentially what we're doing is we're looking at parities, and a parity is just even versus odd. So I'm going to star this because of how important this is actually. But we know our remainder is odd. That is super helpful because now we can say that the only possible remainders are 1, 3. Oh wow, this color is actually not very bright. Let me change this. 1, 3, 5, 7, 9, and 11. However, another thing is clearly we can see that 12 is a multiple of 3. And we know that this 67p squared cannot be a multiple of 3 because, again, p is odd. That doesn't divide 3. 67 doesn't divide 3. That means that the remainders options that we have also can't be multiples of 3. So I can cross these out. 3 and 9 are gone. And now let's just test this, right? Because we're looking at p squared. So let me scroll down again. What I'm going to do is I'm going to square each of these, and I'm going to see what the remainder is when divided by 12. So 1 squared is congruent to 1 mod 12. Fair enough. 5 squared is congruent to 25, which is congruent to 1 mod 12. Interesting. Going again, 7 squared is congruent to 49, which is also congruent to 1 mod 12. Very interesting. Lastly, we have, again, I'm going to scroll. Hopefully this isn't too distracting. 11 squared is congruent to 121, which is congruent to, wow, 1 mod 12. So the amazing thing here is that we can generalize it to no matter what number we have here, whatever our p is, when we square it, it's always going to be 1 mod 12. So this is very, very interesting. So now with this fact, we go back to what we're solving. And let me read it right. We're solving for the remainder when 67p squared is divided by 12. So if p squared is always going to be congruent to 1, let me highlight this here. If this is always going to be congruent to 1, then we just want to look at 67. Now 67 is congruent to 7 mod 12. And let me scroll up so you guys can see this. 7 mod 12. And so when we do 67, aka 7 mod 12, and we multiply this by 1, 7 times 1 is congruent to 7 mod 12. So our final answer is actually just 7 because we've broken it down into the 67 versus the p squared. So final answer is 7. And the really amazing thing here is just we really didn't need to figure out what p was because we could generalize it because we have this amazing fact that all these prime numbers, when we square them, it's always congruent to 1 mod 12. So yeah, hopefully that was pretty clear. And moving on to question number 4, we have some algebra. Suppose that x squared plus 1 equals 3x. Find the value of x4 plus 1 over x to the 4th. So first things first, we kind of want to match the structure here. Right now, everything is a little different. So what I'm going to do is I'm going to divide the first equation, both sides by x. So that's why I get x plus 1 over x equals 3. Now, why does this help? This helps because this mirrors the structure that we have in our second equation that we want to find the value of. So now I'm going to square this. And the reason why I'm going to square this is because something really awesome happens, and it's going to be pretty clear. So if I do square this, I end up getting x squared plus 2 times x times 1 over x plus 1 over x squared, and this equals 9, right? But what's really awesome here is x times 1 over x. This cancels out. This is 1. So essentially I'm left with x squared plus 1 over x squared equals 7 because I subtract 2 from both sides. Amazing. And now why can't I just do the same thing, square it again? Because what I want is x fourth plus 1 over x fourth. So if I do square this again, you'll see that I get something like x to the 4th plus x squared times 1 over x squared times 2 plus 1 over x to the 4th equals 49. Because again, let's not forget to square the right-hand side. Again, amazingly enough, this will cancel out because x squared times 1 over x squared is just 1. So this just turns into 2. So again, continuing this, I'm going to scroll down a little. X fourth plus 1 over x to the 4th is just equal to 49 minus 2, aka 47. I'll write it here. And we're done. So as you can see, that was very fast, very simple. The key step was dividing x from our first equation to mirror the structure of what we want to find. So that's a pro tip here. Anytime you see these algebra equations and they don't really match each other in structure, try to find some way to manipulate it so it does, and then the answer will come pretty clearly. And then finally, for our last question in this video, let me actually move this so you guys can see. There are 40 people in a room, 15 girls, 20 boys, and 5 adults. The average age of the girls is 15, the average age of the boys is 13, and the average age of everyone in the room is 20. What is the average age of the adult? So, the key fact that I'm going to use here is that the average age is just equal to the total age sum, I suppose, divided by the total number of people. So, similarly enough, I can rewrite this as, hold up a sec, the total age, since this total age sum, of course, doesn't really make a lot of sense, I'm going to say the total age is equal to the number of people times the average age. Amazing. So now what I'm going to do is find the total age of everybody. So we know there are 40 people, and the average age of everyone in the room is 20. I'm going to highlight this for you guys. So we have total age of everyone. (40 times 20), following this pattern here. And this is 800. The next thing I'm going to do, if you guys can't already tell, is I'm going to keep on going down. And I'm going to find the total age of the girls. Maybe I'll do pink. Total age of girls. And let's go back to our question to find information. We know there's 15 girls and the average age is 15. So what we're going to do, you probably guessed it, is 15 times 15, 225. And I'm going to do the same thing with boys. So, total age of boys. There's a lot of computation here, guys. But this is just going to be, again, let's scroll. 20 boys, age is 13, average age is 13. So I'm going to do 20 times 13, which is equal to 260. And now to find the total age of the adults, I'm just going to subtract these two from this total. So what I mean by this is I'm going to do 800 minus, where's my pink? 225 minus 260. Because we know we have either girls, boys, or adults. So if I subtract the girls and the boys, I'll find the adults. And this is going to give me something like 315. But going back here, what does this 315 represent? That represents the total age sum, right? This is the total age sum of the adults. But I want to find the average age of the adults. So what I want to do is I'm going to divide the total age sum by the total number of people. So how many adults do we have? We have 5 adults. So the average age of the adults is going to be 315 divided by those 5 people. And this gives me a number like 63, and that's our final answer. So the average age of the adult is 63. So in summary, we use 2 really key things, which is average age is that age sum, that total age, divided by the number of people. And similar thing here, we just rewrote that equation in green. So then I just found the total age of everybody, each category, and then I subtracted the girls and the boys from the total to find the adults. Then I divided the adults by the number of adults to get 63. So that's how you do question number 5 of the middle school competition. Hopefully this video made a lot of sense, and we will also be posting the next 5 questions, so make sure you keep in touch for that. But yeah, other than that, thanks for watching.